Hi everyone, good afternoon. Today we're going to discuss about the part 2 of our polynomial curves topic, which includes concavity and the second derivative test. So first is we need to define concavity. So concavity, let f be differentiable on an open interval I. Same thought with the previous topics katong sa extrema. The graph of the function is concave upward, such as this one, concave upward, on I when f prime is increasing on the interval, and concave downward, such as this one, such as in figure B, on I when f prime is increasing on the interval. So theorem 3.7 states the test for concavity. Let f be a function whose second derivative exists on an open interval I. So unlike sa finding the extrema, the maximum and minimum where we use the first derivative test, here when we are going to test the concavity, we're going to find the second derivative. Okay? So number one, if f double prime, or if your second derivative of x is greater than 0 for all x in I, then the graph of f is concave upward, such as this one, concave upward. And number two, if f double prime of x, or if your second derivative is less than 0 for all x in I, then the graph of f is concave downward, such as this one. So if your second derivative is lesser than 0, so concave downward ang imuhang graph. So a proof of this theorem is given in the textbook. Okay? So in the last slide, I am going to show you the book, no? So katong Larson, I guess na send na ko ni siya sa Google Classroom, na touch na ko ni siya sa Google Classroom. So now let's proceed with the example. So determine the open intervals on which the graph of f of x is equal to 6 over x squared plus 3. So this is your original na function. Ipa-determine ta if it is concave upward or concave downward. So we begin our solution by observing that f is continuous on the entire real number line. Next is we need to find the second derivative. So first, ang atong yapong buhaton, same with sa previous natong topic katong sa extrema, we need to write the original function. So we rewrite it as f of x is equal to 6 times the quantity of x squared plus 3 to the power of negative 1. Then we perform the appropriate differential or derivative rule. So by using the chain rule, so we have negative 1 times 6, we have negative 6 times quantity x squared plus 3 to the power of negative 1 minus 1 now becomes negative 2. Then we have the derivative of the inner part, so 2x, okay? So now we do the simplification and i-rewrite na to siya. So now we have negative 6 times 2x is now negative 12x. Then we have the denominator as x squared plus 3 squared. Okay? So now we perform the quotient rule. So we follow the low d high minus high d low na rule, no, over low squared. So the second derivative now is, so kini man imuhang denominator, no, so quantity x squared plus 3 squared times the derivative of negative 12x, which is negative 12 minus negative 12x, quantity negative 12x times the derivative of your denominator, which is 2 times quantity x squared plus 3 times 2x all over your denominator squared. So we have quantity x squared plus 3 to the power of 4. So by simplification and factoring, so now we have the final answer of the second derivative, which is 36 times the quantity of x squared minus 1 all over x squared plus 3 cubed. So now we begin the tabulation. So using the same table such as the first derivative test FDT, so we need to write the interval, the test values, the sign of the second derivative, and your conclusion. So because your f double prime x is equal to 0, then when x is equal to positive or negative 1, since kini imuhang denominator, if ay imuhang x values imong substitute kay positive or negative 1, and f double prime is defined on the entire real number line, we should test if f double prime in the intervals same gyapon no katong left hand gyapon. So natay negative infinity to negative 1, then we have negative 1 to positive 1, then we have 1 to positive infinity. So same procedure, we need to find a test value in between those intervals. So for negative infinity to negative 1, I chose negative 2. Then from negative 1 to positive 1, I chose 0. Then from 1 to positive infinity, I chose 2. Then we're going to substitute the chosen test value to the second derivative na equation. So let's try using our calculators. So let's just input 36 times the quantity of what? So we have first our test value is negative 2. So negative 2 squared minus 1 all over negative 2 squared plus 3 cubed. Okay, so the answer is 0.31486. So that is the answer. So therefore, it is greater than 0. So therefore, the conclusion is concave upward. Okay? So next one, next test value is 0. So we're going to substitute the values of x with 0. So the answer is negative 1.333. So therefore, it is lesser than 0. Now our conclusion is concave downward. So our next test value is positive 2. So we're going to substitute our test value, which is positive 2, to our second derivative. So when we substitute the value of our test value, the answer is positive 0.31486. So therefore, it is greater than 0. So our conclusion is concave upward in this interval. Okay, so nara sa inyo ha kung unsa ang inyong gamiton as test values. Basta within the range lang. Okay? So for the function f of x is equal to 6 over x squared plus 3. So mo ni siya no ang ato ang interval from negative 1 to positive 1. So from negative 1, makita nato na ang iyahang using our second derivative test no, makita nato nga greater than 0 siya. So ang iyahang concave is upward. Then dinhi sa from f double prime x is lesser than 0, which is concave downward. Okay, so makita nato based sa signs nato dinhi. So pasaka dinhi from negative infinity to negative 1, then from your negative 1 to positive 1, kita na to ang yahang concave downward, then from positive man infinity, no, from positive 1 to infinity, concave upward. Okay, so now let's proceed with the points of inflection. So definition of the point of inflection. Let f be a function that is continuous on an open interval, and let c be a point in the interval. If the graph of f has a tangent line at the point c, f of c, then this point is a point of inflection of the graph of f when the concavity of f changes from upward to downward, okay, or downward to upward at that point. So that is the point of inflection. So kaganina or atong previous topics na to, previous na to tong polynomial curves part 1, ang atong kuan ato is ang critical point, no? A critical point in which mahimo siya og non-differentiable o mahimo imuhang first derivative be equal to 0. So dinhi pod napod tay ginatawag nga point of inflection in which your concavity of f changes from upward to downward or downward to upward. So that is the point of inflection. So by theorem 3.8, the point of inflection na theorem, if c f of c is a point of inflection of the graph f, then either your second derivative or your f double prime of c is equal to 0, or your second derivative or your f double prime c does not exist. So pagkatong sa ekstrema, ang atong ginapangita ato is ang critical point, which is gina-equate nato ang iyang first derivative to 0 or non-differentiable siya. Here ang iyang equivalent is ang point of inflection. Okay? So for example, the f of x is equal to x to the 4th power minus 4x cubed. No, makita nato ang shift niya from upward to downward na concavity, and from downward to upward na concavity. Okay? So makita na to. So this point is the point of inflection. So points of inflection can occur when your f double prime of x is equal to 0 or it does not exist. So for example, let's determine the point of inflection and discuss the concavity of the graph. Of f of x is equal to x to the 4th power, kini ato ang graph din x to the 4th power minus 4x cubed. So for the solution, we need to find the second derivative. So first, we're going to write the original equation, then we perform the first derivation. Then after getting the first derivative, we're going to proceed with the second derivative. So the derivative of x to the 4th power is 4x to the power of 4 minus 1, which is 3, minus 4 times 3, which is 12, x to the power of 3 minus 1, which is 2. So now let's solve for the f double prime of x. So by continuation, no, imo na pong i-derive ang atong first derivative. So now 4 times 3, which is 12x to the power of 3 minus 1, which is 2, minus 12 times 2, 24, x to the power of 2 minus 1 now becomes 1. So by simplification and factoring, so now we have 12x times the quantity of x minus 2. Therefore, our values or ang atong roots ani is 0 and 2. Okay? When we use our calculator, masolve gyapon natin siya by manually solving, masolve gyapon na using factoring. Okay? So by equating f double prime of x be equal to 0, so now we can get that the point of inflection occur at 0 and 2. And by testing the intervals determined by these x values, so we can conclude that they both yield points of inflection. Okay? So then using the interval 0 to 2, tapos negative infinity to 0 and 2 to positive infinity. So using the same table, the interval, test value, sign of your double prime x, then conclusion. So from negative infinity to 0, I chose ito's test value of -1, where it shows that when x is equal to -1, kung ato siyang i-substitute sa ato ang second derivative, which is 12 times the quantity of -1 squared, minus 24 times -1. So the answer is 36. Okay, so the answer is 36, therefore it is concave upward. So now let's choose another test value from the range of 0 to 2. So we chose 1. So you can choose whatever number between 0 to 2. So the answer is -12. Okay? So next, the test value from 2 to positive infinity. So in this example, I chose positive 3. So we're going to substitute positive 3 to the second derivative. So the answer is positive 36, which is greater than 0. Therefore, it is concave upward. Okay, so now let's proceed with the second derivative test. By theorem 3.9, the second derivative test. Okay, so now let's proceed with the second derivative test. So let f be a function such that your f prime of c is equal to 0, and your second derivative of f exists on an open interval containing c. So number 1, if your f double prime of c is greater than 0, then f has a relative minimum at c f of c. While if f double prime of c is lesser than 0, then f has a relative maximum at c f of c. And if f double prime of c is greater than 0, then the test fails. So that is, f may have a relative maximum, a relative minimum, or neither. In such cases, you can use the first derivative test. Okay, so now let's proceed with the example. Let's find the extrema of f of x is equal to -3x to the 5th power plus 5x cubed. So we start by finding the first derivative, of course, no? So we need to rewrite the equation, the original equation, then we perform the first derivation. So -3 times 5 is 15, x to the power of 5 minus 1, which is 4, plus 5 times 3, which is 15, x to the power of 3 minus 1 is 2. So we have -15x to the 4th plus 15x to the x squared, So we factor it out and simplify. So we have, ipagawas na to si x squared since common man in both terms. So we have 15x squared times the quantity of 1 minus x squared. So from this derivative, we can see that x is equal to -1, 0, and 1 are the only critical numbers. So makita na to ang iyang critical numbers of f. And by finding the second derivative, kung ato ni siyang i-derive, so our answer is -15 times 4, which is -60, x to the power of 4 minus 1, which is 3, plus 15 times 2, which is 30, x to the power of 2 minus 1, which is now 1, is equal to 30x times the quantity of 1 minus 2x squared. So ato siyang gikuha na to ang iyahang similar na factor. Okay, so gipagawas na to si 30x. So now we can apply the second derivative test shown below. So naagyapon tay table with point, the sign of f double prime of x, and your conclusion. So at point -1, -2, 0, 0, and 1 to 2. Okay, since ang ato ang points dinhi, no? Hello, so basin matingala mo kung asa nigikan si -2 and +2 dinhi. So since ang atong x values from the critical number sa iyang first derivative, so we have -1, 0, and 1. So ang atong gamiton, so i-substitute nato si -1 dinhi sa ato ang original equation na f of x is equal to -3x to the power 5 plus 5x cubed. So makita nato ang iyahang y coordinate. So now sa value nga -1 nga x, the answer is -2. And for 0, it's 0. So na siya sa ato ang origin. Next is sa +1. So i-substitute lang nato siya. So +1. So the answer is +2. So we need to find the sign of f double prime of x. So when we test the value -1 katong gikan sa imong critical number, so when we use the -1 sa ato ang second derivative test, so if we apply or if we substitute -1, so -60 times the test value or the value of our critical point, which is -1 to the power of 3 or cube plus 30 times -1. So the answer is +30, which is greater than 0, therefore our relative minimum. Since pag greater than 0, relative minimum, ayaw mo ka-confuse for the second derivative. Pag yung second derivative is greater than 0, it has a relative minimum, while kung lesser than, it has a relative maximum. So now let's substitute the value of 0. So 0, kung i-substitute na to siya sa itong second derivative, makita na nato visually na the answer is 0. So therefore, the test fails at 0.00. So next point is +1. So if we substitute the critical point 1 to our second derivative, the answer is -30, in which our conclusion is a relative maximum. Okay? So because the second derivative test fails at the origin 0, 0, we can use the first derivative test and observe that f increases to the left and right of x is equal to 0. So the origin 0, 0 is neither a relative minimum nor a relative maximum. So even though the graph has a horizontal tangent line at this point, so at this point 0, 0. The graph f is shown in the figure below. So the function f of x is equal to -3x to the 5th power plus 5x cubed. So at point -1, -2, it is a relative minimum, -1, -2, and at point 1, 2, relative maximum. And at point 0, 0, neither relative minimum nor relative maximum. Okay, so for our summary sa ato ang topic for this week, which is all about polynomial curves. So for our first derivative test, when y prime is positive, therefore the curve is increasing. When y prime is negative, therefore the curve is decreasing. And if y prime is 0, it is a possible local maximum or minimum. And for the second derivative, if y double prime is positive, therefore the curve is concave upward. And if y double prime is negative, therefore the curve is concave downward. And if y double prime is 0, it is a possible point of inflection where your concavity changes from either concave upward to downward or downward to upward. Okay, so that's all for our part 2 sa atong polynomial curves topic, and attached here is your assignment number 6 where you're going to submit it until Sunday. Okay, so please study ahead of time no kay mag-quiz ta next week. So thank you everyone.